This is 6.1, lesson 1. So for this lesson, we are going to determine if numbers are rational. Now the word rational includes the word ratio, and ratio means a fraction. Okay, so our definition of a rational number is going to be a number that can be written as a ratio or a fraction of two integers. Okay, so some examples are some regular fractions, 1/2 or 1/4 or -5/9. Those are all just regular fractions that are rational. Okay, we also have mixed numbers like 3 1/2, -2 1/3, -5 6/8. Again, all these are rational because they can be written as a fraction that includes two integers. Integers are positive and negative numbers, including 0, but it does not include decimals. Okay, so integers are most likely people want to think of them as whole numbers, but it also includes the negatives. So some percent examples are 70%. 70% is the same thing as 0.7, which is the same thing as 7/10. Again, 70% can be written as a fraction, so it is rational. If you do the same thing with -0.8%, that is the same thing as -0.008, which can be written as -8/1000, and then simplified, which again is a fraction, so it is rational. We also have decimals like 0.45. This decimal can be written as 45/100, which again is a fraction of two integers. But we also have decimals like 0.3 repeating. 0.3 repeating is 1/3. So again, it's a fraction with two integers. So as far as decimals go, we can have regular decimals, terminating decimals, but we can also have repeating decimals as being rational numbers. Also not listed in this category are integers. So integers can be like -2, 0, 5. It's our positive, negative numbers, and 0, but it's none of our decimals or fractions. So rational numbers can be fractions, mixed numbers, integers, percents, and terminating and repeating decimals. So what does that mean non-rational numbers are? So some non-examples include numbers like pi, or numbers like 2.162563, and it goes on forever. These are non-examples because both pi, which is 3.14159, so on, and our second number here are both decimals that do not end and they do not repeat, and neither one of these numbers can be written as a fraction. These numbers are called irrational. We will go into more detail in future lessons about irrational numbers. So a terminating decimal is a repeating decimal where the repeating digit is 0. So for example, if I had the decimal 0.45, I could say this is 0.450000, and so on. But really, we see it as this decimal ends after the 5. So it terminates, it ends. Terminating decimals, we already talked about, are rational numbers. A terminating decimal is a decimal form of a rational number. So the relationship between rational numbers and ratios is that all rational numbers can be written as ratios. So our first example is a review, and it says to change each fraction or mixed number to a decimal. So to change 5/8 to a decimal, I'm going to do 5 divided by 8. We know that 8 goes into 5 0 times. So I put my decimal after my 5 and I add another 0. 8 goes into 5 6 times, and 6 times 8 is 48. So I'm left with a 2. I bring down another 0. 8 goes into 20 twice. So it's going to give me 16 with a 4. And then 8 goes into 40 exactly 5 times. So my decimal is going to be 0.625, or 625 thousandths. Letter B, 3/4, is a common fraction that you might already know the decimal to. But if you don't know it, we need to go ahead and show our division. 3 divided by 4. We know 4 goes into 3 0 times, so we go ahead and put our decimal in our 0. 4 goes into 37 times, so it's 28. I'm left with a 2, and I bring down a 0. 4 goes into 25 times, so 0.75 is the same thing as 3/4. Negative 1 2/3, we already know we're going to have negative 1 point something. We don't have to change this to be improper in order to figure out what the decimal is. All we have to figure out is what 2/3 is as a decimal. Again, this is a common one. You might already know it, but if you don't, we need to show our division. 3 goes into 26 times. So it's going to give me an 18. And when I subtract, I get a 2. I bring down a 0. It's going to go in 6 times again. And this pattern is going to continue. So the way we're going to write this number is negative 1.6 repeating, with this bar over 6 representing that 6 is going to continue to repeat. Then we have letter D, 3 1/11. So we know this one is going to be 3 point something. And we need to go ahead and do 1 divided by 11 to figure out our decimal. We know that 11 goes into 1 0 times. It goes into 10 0 times. It goes into 100 9 times. So that's going to give me 99. I'm left with a 1. I bring down a 0. 11 goes into 10 0 times. So I bring down another 0. 11 goes into 100 9 times. And this pattern is going to continue. We can see that our 0.09 is what is repeating. So when I write my 09, I'm going to put a bar over both, representing that they both repeat. Letter E. So we're going to write each ratio and then change that ratio to a decimal. So letter E says, in a recent season, the St. Louis Cardinals first baseman Albert Pujols had 175 hits and 530 at-bats. To the nearest thousandth, find his batting average. So our original fraction is 175 over 530. Now you can go ahead and do 175 divided by 530 to find your decimal, or we can simplify this fraction. Both of these numbers are divisible by 5. So if I do 175 divided by 5, 5 goes into 17 3 times. Left with a 2, and then bring down a 5. 5 goes into 25 5 times. So my top number is 35. Then I do 530 divided by 5. 5 goes into 5 one time. 5 goes into 3 0 times. And I bring down my next 0. 5 goes into 30 6 times. And we know it's 106 and not 16 because 530 started off as a bigger number. It wouldn't make sense for my denominator to be smaller than my numerator because that's not how my fraction originally started. Now we can go ahead and do 35 divided by 106. Okay, well we know 106 goes into 35 0 times, so we can go ahead and add our decimal. Then if we were to guess how many times 106 goes into 35, we would probably guess 3. And 3 times 106 is 318. When I subtract, I get 32. I bring down a 0. 106 goes into 320 3 times, because we already know that's 318. So I bring down a 2. Or I get 2. I bring down a 0. 106 goes into 20 0 times. Now what we need to pay attention to is how many we need to go to. So it says the nearest thousandth. 0 is in my thousandths place, but I need to go one further to know where to estimate or how to estimate my 0. So we know 106 goes into 200 only one time. So we're going to approximate this to be about 0.330. Letter F. In recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races held. To the nearest thousandth, find how many races he has won. So our original fraction is 6 over 36. This does simplify. They're both divisible by 6. So this is going to give me the fraction 1 over 6. So we need to go ahead and divide that out. 1 divided by 6. 6 goes into 1 0 times. We add our decimal. 6 goes into 10 once. I subtract and I get a 4. 6 goes into 40 6 times. So I get 36. Again, I subtract and I get a 4. It goes into 46 times. And we're going to continue this pattern of our 6's repeating. So the exact answer would be 0.16 with a bar over the 6. However, I asked for us to round to the nearest thousandth, which would mean that I do 0.16 and then I need one more number, which would be this place right here. But since I have a 6 afterwards, it's going to make my 6 round up to a 7. Letter G, write 0.45 as a fraction. So 5 is in the hundredths place. We can even read this decimal as 45 hundredths, which means that I'm going to put 45 over 100. Both of these numbers are divisible by 5. 45 divided by 5 is 9 over 20. And our last one, negative 14 hundredths. Again, this works the same. We have negative 14 over 100. Both of these numbers are divisible by 2. So on the top I get negative 7, and the bottom we get 50.